Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to be looking at something new called average rate of change. But when I say new, I don't really mean all that new. Yes, the words might seem new to you, but you've already seen this topic if you've dealt with slope. Average rate of change is another way of saying slope, in some senses. Because oftentimes in algebra, you'll be working with functions that are not straight lines. Since slope is a constant rate at which a line is increasing or decreasing, you will use average rate of change to determine how fast any function is increasing or decreasing. So the difference between average rate of change and slope is that you might be looking at some curvy lines, and with that line curving, it's constantly changing its slope. So the average rate of change says what its slope is over a certain interval, what its rate of change is over a certain interval on average. So it can be represented by the following formula. And can you see how this formula right here is similar to the slope formula? So remember, slope formula is y2 minus y1 over x2 minus x1. Or you may have seen it as the change in y over the change in x. That's exactly what this is saying because you're used to seeing f of x. So this is the second y minus the first y, there it is, and over the second x minus the first x. So given the function 3 times x minus 1 plus 4x, find the average rate of change over the domain interval of 0 is less than or equal to x is less than or equal to 4. So what we're going to do here is we're going to start with our smallest value. We're going to substitute that into the function. And then we're going to do the same thing with our largest value. Because right now we know our x values in each of our coordinates. We know it's going to be 0, comma something when we plug it in. And we also know that it's going to be 4, comma something else when we plug that in. And using those 2 points, we're going to be using our average rate of change formula to figure that out. All right, so start with substituting in 0. So we're going to have f of 0 is equal to 3 times 0 minus 1 plus 4 times 0. And that means that f of 0 is going to be 0 minus 1 is negative 1, 3 times negative 1 is negative 3, plus 4 times 0, which is 0. So we're going to get a negative 3 here, which also means that that's my first coordinate point. It occurs at 0, negative 3. And we're going to do that same thing with 4. So now we're going to substitute 4 in for x, and we're going to get 3 times 4 minus 1 plus 4 times 4. So again, we'll simplify this a piece at a time. 4 minus 1 is 3, times 3 is 9. This will give me 9 in the first part, plus 16. 9 plus 16 is going to give me 25. So in my second coordinate point, I'm going to have 4, comma 25. Now that I have my 2 points, I can use my average rate of change formula or slope formula, whichever you prefer. And you're going to go ahead and you're going to subtract your second y value, 25, minus your first y value, which is negative 3. And you're going to divide that by your change in your x values, which is 4 minus 0. And what you'll get there is 25 minus negative 3 will give you 28 over 4. And that means your average rate of change is 7, because 28 divided by 4 will give you 7 as an answer. So right here, the average rate of change over the domain interval from 0 to 4 is 7. We're going to do that same thing now from negative 2 to 2. So again, we know our smallest value here is negative 2, and we know that we're going to go up to our largest value of positive 2. So we know our two x values in our two coordinate points. We know negative 2 comma something and 2 comma something. So again, we're going to go ahead and we're going to substitute in the negative 2 first. And we have f of negative 2 is equal to 3 times negative 2 minus 1 plus 4 times negative 2. We could simplify this all at once, just like we did in the previous part of the exercise in part A, and we'll do negative 2 minus 1 is negative 3. Negative 3 times 3 is negative 9. Negative 9 plus negative 8 will be negative 17. So we're going to get negative 2, negative 17 right here. But now we need to find our other end of our domain interval, which is going to be 2. So we'll go ahead and substitute 2 in for x, and we'll get 3 times 2 minus 1 plus 4 times 2. All right, so again, simplify it all at once. 2 minus 1 gives me 1. 1 times 3 is 3. 3 plus 8 is going to give me 11. So when I substitute 2 in, I get 11 as a y value. So again, now we want to go to our average rate of change formula. Whichever one of these three you prefer, they're all the same thing. And we're going to do our second y value, 11, minus our first y value, negative 17. And we're going to divide that by our change in our x values, 2 minus, and we have a negative 2 in our first x value. And that'll simplify again over here to 11 plus 17. That's going to give me 28 over 4 again. And average rate of change is going to be, what do you know? It's going to be 7 again. And the reason for this is if we were to actually simplify this equation, we're going to have 3x minus 3, and then plus 4x, which will then simplify to 7x minus 3. And this right here is a linear equation, and it's linear because it's in the form of mx plus b, which we'll be talking about later on. And that m value is our slope, or our average rate of change, and in this case it's always going to be 7, because as it's set up above, linear equations have a constant rate of change, and this constant rate of change is going to be 7. So if this video is helpful in seeing the first exercise in average rate of change, give it a thumbs up. You're now ready for exercise number 2, and you can click on the link in this video to get there. Thank you for watching.